Let's have a look now at something called annuities, and that's the next part of our course. We're going to spend the next several weeks in here learning how these things work and how we can solve them. And today I just want to take a few minutes to give you a quick introduction to the terminology and the types of variables we're going to use, and really just the key concepts as well. Sometimes in finance or just in life in general, we have a situation where we have multiple payments taking place over time. So that's payments or deposits. Maybe a car loan, for example, would have 60 monthly payments if it was a 5-year car loan. Or maybe we're saving for retirement and we want to put in a certain amount on a regular basis into our retirement account. Maybe it's $500 a month or $500 a year or something like that, whatever it's going to be. It's going to take place regularly and it's going to take place over a long period of time. When we have situations like that, we're looking at examples of annuities. So what is an annuity exactly? Well, it's a regular stream of payments over time. The key thing being, though, that the payments are equal and they occur at regular intervals. The $50 a month might be an example. Let's say I set up a timeline like this, and on the side here I've got months on the go. Well, here's my $50 amounts. There's 8 of them. One at the end of each month, right? So here's the first kind of monthly time frame right here. This $50 payment happens at the end of that, or right at 0.1. And this one here covers me off for the second. This is for the third, the fourth, the fifth, the sixth, the seventh, and the eighth. And sure enough, if we count them up, we have 1, 2, 3, 5, 6, 7, 8 payments of $50. They're evenly spaced out, and they're the same amount each time. The time between payments, that's called the payment interval. So let's have a look. There's one right here. Here's a payment interval. Here's another one. Here's another one, etc. all the way along. Here's the very last one in the annuity. If the annuity stopped here at payment number 8, it goes from 7 up to 8, doesn't it? At the interval. It's like the payment, if I do an oval instead, happens at the end of that period, right at 0.8. Same thing down here at the beginning. Let's look at that. Here's the first interval. The payment I know is at spot 1, but it was for the whole period. It's at the end of that period, which means the period must have began down at 0. And that's just naturally how we count, isn't it? We never say 0, but we know it's always there. So the time between payments is a payment interval. The time from the beginning of the first interval up until the end of the last interval, that's called the term of the annuity. Notice that the term began right at the 0 mark down here as well. The future value of an annuity is an equivalent dated value of all the payments due at the end of the term. So it's like I put my focal date down here at the end of the term. Here's the term, remember? And I said I want one number that's going to be equivalent to all of those numbers on the top. Now, you've already done equivalence with just a few dollar amounts. Here we just have many more. That's the only difference. And what if I wanted to do the present value? Well, present value is down here at 0.0. It's like I put my focal date at the very beginning, and I said, okay, let's bring all those dollar amounts back to 0. Discount them all back like that, one after the other. And when I get there, add them all up. Well, that's going to be my present value. The key thing to remember, the present value is at 0.0, which is actually the beginning of this first interval here. Not necessarily where the first payment is, but where the first interval is. And that's the key thing as well to think about. We're talking about the beginning of the period for 0.0. Present value, future value. A couple more terms that you need to know. Simple and general annuities. Simple are when the payment interval and the interest periods match up. So for example, if I had monthly payments and the rate was a J12, a monthly compounded rate, that's a simple annuity. If I had quarterly payments and the rate was a J4, that's also a simple annuity. But if I had monthly payments and the rate was a J4, they don't match, do they? The payments are monthly, but the rate compounds quarterly. That's called a general annuity. We're going to start this week with simple annuities, Next week we'll learn how to deal with sort of the extra little step we have to do in the case of a general annuity. Now the last thing we need is some notation. We're going to use PMT to stand for payment. That kind of makes sense, so we'll use that. And here's the good news. The other variables we're using are just our normal compound interest variables, aren't they? Those are the ones we've been using all along for compound interest. Why do we use the same variables again? Well, because annuities use compound interest. So that's perfect. So we've already learned a lot of what we need to know about the individual variables. The only new one is PMT for payment, and now we can use that as well. So there you have it. Those are the basics that we need before we can get going. Work through the first little section of the book. That won't take too long. And then when you're ready, we can move on to our first kind of topic where we do some calculations, and that's calculating the future value of annuity in our next video.